Imagine standing in NASA mission control room when a new transmission arrives from Mars. Nothing unusual at first, just another packet of data traveling across millions of kilometers of empty space, the kind of signal engineers receive every day.
So this very well could be the clearest sign of life that we've ever found on Mars, which is incredibly exciting.
We look at everything we know about life on Earth. And this is the kind of signature that we would see that was made by something biological.
Something appears on the screen. A pattern, a chemical signature, a detail hidden inside an ancient Martian rock that shouldn't be there. The room falls silent because for the first time in decades of exploration, scientists may be looking at one of the strongest clues yet that Mars was once a living world. Not today, not advanced civilizations, not little green aliens, but something potentially even more important, proof that life can emerge beyond Earth. And if that's true, everything changes. For generations, Mars has captured the human imagination. Ancient civilizations saw it as a wandering red star. Writers imagined canals and alien societies, and scientists dreamed of oceans hidden beneath the dust. Today, we know Mars is a frozen desert covered by iron-rich soil, a world where temperatures can plunge far below anything experienced on Earth, and a planet constantly bombarded by radiation. At first glance, it seems completely hostile to life. But Mars wasn't always this way. Billions of years ago, the planet looked remarkably different. Rivers carved valleys across its surface, massive lakes collected water for millions of years, rain may have fallen from thick clouds, and an atmosphere much denser than today's protected the planet from harmful radiation. In many ways, ancient Mars may have resembled a younger version of Earth. And that's exactly why scientists are interested in a place called Jezero Crater. Today it looks barren and lifeless, but orbital observations reveal something extraordinary. Jezero was once a gigantic lake. An ancient river flowed into it, depositing sediments that remain preserved today. On Earth, environments like these are excellent at preserving traces of ancient life. If microbes ever existed on Mars, Jezero Crater is one of the best places to find evidence of them. That's why NASA sent the Perseverance rover there. Since landing in 2021, Perseverance has been exploring rocks that formed billions of years ago, and what it has found is fascinating. One of the rover's most important discoveries involves organic molecules. These carbon-based compounds are the building blocks of life as we know it. Finding organic molecules does not automatically mean life existed because they can form through non-biological processes as well. But their presence proves that some of the chemical ingredients necessary for life once existed on Mars. In several locations, Perseverance has detected surprisingly complex organic chemistry preserved inside ancient rocks. The story becomes even more interesting when scientists examine where those molecules were found. Many were discovered in rocks formed in watery environments, exactly the type of locations where microbial life could potentially have survived billions of years ago. Then came another surprise. Perseverance identified rocks containing minerals that typically form in the presence of water. Some of these formations show fine layers and textures that remind scientists of structures created by microbial communities on Earth. No one is claiming these are fossils, at least not yet, but they are intriguing enough that researchers want to investigate further. Perhaps the most exciting part of the mission is happening right now. Perseverance is collecting carefully selected rock samples and sealing them inside special tubes. These samples represent some of the most scientifically valuable material ever collected on another planet. Why is this important? Because the instruments inside a rover can only do so much. The most advanced laboratories on Earth are thousands of times more capable. Scientists hope that one day these samples will be returned to Earth, where they can be studied using technologies impossible to send to Mars. And that future analysis could finally answer one of humanity's oldest questions: was Mars ever alive? The implications are enormous. If scientists discover evidence of ancient Martian microbes, it would mean life emerged independently on two different worlds in the same solar system. That would suggest life may not be rare at all. Instead of being a cosmic miracle, it might be a natural consequence of the universe whenever the right conditions exist.
We found what we believe to be signs of microbial life on the Mars surface. And so we put it out to our scientific friends to pressure test it, to analyze it, and go, did we get this right? Do we think this is signs of ancient life on Mars?
Suddenly, billions of planets across the galaxy become far more interesting. Every distant world orbiting another star becomes a potential home for life, and every ocean hidden beneath the icy moons of Jupiter and Saturn becomes a possible ecosystem waiting to be explored. The discovery would reshape biology, astronomy, and our understanding of ourselves. Yet scientists remain cautious. History contains many examples of exciting discoveries that later turned out to have simpler explanations. Extraordinary claims require extraordinary evidence. That is why every observation from Mars undergoes rigorous testing. Every possibility is challenged. Every alternative explanation is examined. Science moves slowly for a reason, because when the answer finally comes, it must be correct. For now, Perseverance continues its journey across Jezero Crater, day after day, rock after rock, searching for clues hidden for billions of years beneath the Martian dust. And somewhere among those ancient stones may lie the answer humanity has been seeking since the dawn of civilization. Were we the first living world, or are we simply one chapter in a much larger story written across the cosmos? Mars may hold the answer, and for the first time in history, we're close enough to ask.